Okay, so this is what a vector would look like on our graph. You guys see how it's like an arrow? And it has a quantity that has both magnitude and direction. And we'll talk about both those things in a moment. But this is what you're going to be looking at today. These arrows. Some examples that have length and direction are like airplanes flying at 400 miles per hour. And I'm not like an aviation person. I'm not sure how you read the. I don't know if that's N stands for newtons or if it stands for north. I'm not really sure. North. But then what would the east be? North 30 degrees east. Sorry.
Because you're going northeast.
It seems to me to make more sense to just have northeast stuff.
You have to stand down.
Yeah. Or if you watch the news, like wind patterns, they show you in vectors. Those are all vectors. So now when you watch news with your parents, you're like, hey, I know what that is. It's a vector. Magnitude and direction. Okay. Let's just see how good we are. What part of the United States is showing? Can you tell?
What?
Can you tell what part of the United States this is like zoomed in on?
Florida.
California.
It's Florida.
Tornado watch.
Oh,
No.
northeast.
It looks like I have no. Kentucky.
Colorado.
What state has a panhandle?
Tennessee.
Oklahoma. Okay. All right, what's next? Magnitude. All magnitude of these guys is how long. It's the length from your initial point to its terminal point. So where it starts to where it ends. Your initial point is the dot typically, and your terminal point has the arrow. And all you're going to do to find that length, guys, is Pythagorean theorem. Super simple. Okay. So magnitude is how long it is. And its direction is just the angle it makes with the x-axis, the positive x-axis. So we'll be able to calculate this angle right here by using one of our trig functions. We'll draw on our triangle, and that's what we've been doing all last week, okay? That's our direction, the angle. And then one more little thing to talk about, it's component form of a vector.
You figured out that? You figured out how to get there?
Oh, yeah.
Okay, the component form of a vector is described in terms of its horizontal change and its vertical change y from its starting point to its ending point. So really, we can just write this in a more simpler form. And it kind of looks goofy, but it's like a V on its side. So your change in X, we're just going to call it X for now. Your change in Y with another little V on its side. That's its component form. So let's try an example of that right now. It says write the component form of the vector. So let's start with vector PQ. So here's vector PQ, and you put a little arrow on top so you know it's a vector. But it only has like one of the arrow things on this head. Looks like a check on its side almost. Okay. So you start with your terminal point, so the one that has the arrow. So I'm going to take -3 minus -1. So -3 minus -1. I'll get you your notes. And then what would our y be, guys? -1 minus 3. -1 minus 3.
So it's plus.
Yep, and now we just simplify. So what is negative 3 minus negative 1? Negative 2. What's negative 1 minus 3?
Negative 4.
Negative 4. So that would be the component form of PQ. You just subtract your ordered pairs.
That's really, so it's just started off.
Yep, you
Negative 3.
minus negative 1.
Is there like a comma or?
Yep, so it's an ordered pair. And the next one says negative 1 minus 3. So all you're doing, guys, is taking your terminal point and subtracting the starting point. That's all you're doing, subtracting your ordered pairs. So will you do D vector CD on your own before I do it? Try vector CD component form. Or 2? You're just taking your terminal point and subtracting your starting point. All you're doing. You okay with that? Okay. Now let's try find the magnitude and direction of a vector. So start off by plotting your points.
That one's done.
If you're wondering how to tell which one's your starting point and which one is your terminal point, whatever letter is listed first, that's your starting point. So that's how I know R is my initial point. Okay, so let's start with the easier one of the two. So let's start with the magnitude. And all you're going to do is draw in a right triangle. So I'm going to bring this side down. And I'm going to go over. You guys agree that that's a right triangle?
Yes.
Yep. Okay, how far over is R from this point right here? 5. And how many up from this point to T? 6. Now, do you guys see how we can do Pythagorean theorem?
Yes.
5 squared plus 6 squared gives me x squared. Seven point. Perfect. Is anyone confused how I got that part? No. Okay, now this part's a little goofy. So remember, to find the direction, I have to start at the origin because I want to put the positive x-axis. So if I do it from here, I can't because my starting point isn't right there. So I have to move my starting point to the origin. So I'm going to erase this real quick. And would you guys all move your R to right here for me? Now, how many over and up was t from r? Do you guys remember? It was over
5.
and up 6. So can we do that? Can you count over 5, up 6 to get our new t? Now we're just going to have a problem like we had last week. So I know this is 5, and I know this is 6, and I'm looking for this angle right here. So what trig function would I have to use?
10.
Yeah. So for our direction, I can use the tangent of x is equal to
6 over.
6 over 5. Now, when you're looking for an angle, is that the inverse or the regular tan? Inverse. I got 50.2.
So we get the direction. Why do you have what's the direction?
So the direction is essentially at what angle is this vector moving at. So that's why. And it has to be with the x-axis. So I had to move my vector so it was making a side with the x-axis. So really, every time you're going to do Pythagorean theorem to get your length, and then you use the tangent function to get your angle every time, over and over. Can you start by finding the magnitude on the next one, then stop? Don't do the direction yet. So find the magnitude on the next one, then stop.
Does it matter which way you make the triangle?
No, you could have went up and over. That would have been, you would have got the same answer. Find the magnitude, then stop.
Would it be S for the angle you'll use?
If you're going to put S over here. Is that what you're saying?
For the magnitude, for the beginning.
Did we get a bunch of 8.6s around the room?
Yeah.
Okay. So we're going to start the same way with finding our direction. So we're going to move, I'll test you. Which point am I moving, S or T?
S.
Yeah, we're going to always move the first one. Your starting one, so I'm going to move S right here.
Why do we have to move it? Because doesn't it not change your answer if you don't move it?
We'll see. We'll see. But you're right, this seems kind of redundant to redraw this triangle. I agree. And some of you might be able to make the connection and not have to draw, but some of us would just make mistakes, so I'd rather have you draw and be safe than not do it. For this example, I'll show you why. How am I going to find T from here? Where do I go? Perfect. 1, 2, 3, 4, 5. 3, 4, 5, 6, 7. Now I'm going to connect So are we okay up to here, guys? Okay. Now remember, you make your triangle with the positive x-axis, so I'm going to draw in my triangle. And really, these numbers should be the same. It should still be 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Okay. Now we're looking for this angle right here. So what trig function is that? Tan. All right. So we're going to have the tangent of x is equal to what? 5/7. Anyone want to tell me what you get? 35.5?
Yeah.
Okay, but here's the tricky part on this one. You're right, this angle right here is 35.5, but technically this vector started, I need a different color, over here and wrapped all the way around and got to this point here. So what really would be my direction?
How do you know that?
Because it starts at the positive x-axis and it comes all the way around to here.
I don't.
Oh,
Okay.
How'd you get that?
324 is
Yeah.
minus the whatever 35 or whatever minus 360.
So all the way around would be what, guys?
360.
360, and we just found this angle in here to be 35.5. So we have to subtract it. So that's why you always move your vector to a starting point so you can see where it falls. I know, that is tricky. Okay, start off on the next one. Same idea.
We just make it right on the line anyway.
If you want to.
Monday.
Yeah, buddy.
I'm gonna be gone on Monday through Wednesday next week.
Okay. I'll get you what you need. Don't create too much work for yourself. If it's straight up and down, so vertical or horizontal, can I just count the length?
Yeah.
Yeah. So what would my length be here?
6.
6. And if I drop down my vector, what is it? 6, 1, 2, 3, 4, 5. Is he right? Is Sean right? Is my vector going up any?
No.
Or is it just laying flat on the axis?
Laying flat.
So I'm going 0. Not moving at all. 0 degrees. Good work, team.
But if it was straight up and down, wouldn't it be undefined?
There's like straight up and down. It'd be 90. Because like this is 90, that's 180, 270, all the way across 360. Okay, one more little thing we gotta talk about. It says copy the vectors to find the sum and difference. What does sum mean?
Adding.
Add. What does difference mean? Subtract. Okay, so we're gonna start with adding the sum. So I can cheat a little bit and you guys can't, but which is good, otherwise you would have no idea what I'm doing up here. So what you do is you start with your first vector and you're gonna copy it so it has the same slope and length, but just kind of eyeball it, okay? But I have the beauty of just kind of duplicating mine like this. So you guys just do yours. I can show you my notes. Like I was like you, I just kind of wung it. Just draw this right here, okay? Just draw it. Try to make it as close to this as you can. The same slope, so it's increasing at the same rate, and the same length, okay? And now when I add, I'm going to take my other vector, and it's going to have the same. Oh, I didn't think about this. It's not going to work.
Put the
So I'm going to do it like this
put the
here.
A above it.
They're going to have the same. Hang on, you guys are going to see how bad I am at this. Ooh. Right? Just try to make it as close as you can. Feel me? Right? So far, so good. And then you're going to copy this guy over here like that.
Copy B.
We're going to copy A like this. So really you're just like closing up your box.
And then you copy B again.
Yep, then you're going to copy B again on top. So you should make a little bit of a parallelogram.
Would you rate B?
And then your actual answer is the vector you create from this corner to that corner. So that is your answer.
Why do we need to draw the extra A and B? Shouldn't we just draw one and then make a triangle out of it?
You could. You definitely could. Like really you could have drew in the red one and then connected them. Made that and then done. Okay? So the only difference from the sum and the difference is you're going to start off the same way by copying down your first one. So copy down A. But with your second vector, guys, you change its direction. So do you guys see how I'm pointing to the right now? I'm going to flip it so it points to the left. And then you connect it. All right, let's try this. And then do the same thing. Copy your A again from here. And here's our answer. Oops. Kind of goofy. Okay, start the next one and I'll slowly put up what I get.
We're just doing sum and difference again?
Yep, that's it. That's all.
And now we're gonna have to put in numbers. And then it's gonna be hard.
Nope, we're done. This is it.
You don't even have to put numbers.
No numbers.
So
Will
what
there
would
be
be the
numbers
next one?
tomorrow?
What's that?
What are the numbers with this tomorrow?
This is it for a chapter. Oh, I'm off on that one.
Oh, let's go.
Were we kind of close?
Yeah.
Is it kind of going in that direction on your paper?
Does it
Yeah.
matter which way you like the middle?
As long as it connects to your corner.
Can it go the other way?
Like this way?
For
Then
the
we did it
sum,
wrong.
for the sum, if it goes to the
It
left.
should go in this general direction.
How do you know which way?
I will be putting a block.
Alright.